we this week have to take Chapter 2 test. So I'm going to open up. I'm going to go to the pre-cal page here. I'm going to show you what's on task for this week. This is Chapter 2, and we have to take the Chapter 2 test. This is going to be 20% of your grade. I sent out a document through your DISD email that you can play around with what your grade is and what you need to make for your final average that you want. So this is a test that we will be taking. It's open until Friday at midnight. So you have to take it by Friday at midnight. Today is the test review. So here's your attendance link, which I just had up on the screen. There's a YouTube, but if you wanted to have a blank copy, if you're at home, you got a printer, or if you have an iPad or something like that, you want to download it to so you can look, or maybe you just download it to your phone. So as you're watching me work, you can see where the problems come from. This is the exam review that I'm working through today. Okay, so my goal is to see how many of these 18 problems, I'm going to try to get through all of them, we can do in class. Now, I know it's a little different when students ask questions because we can spend more time on a problem. But that's my goal, is to work through this exam review. So if you have a printer, I'd recommend you printing that off. Among other reasons, when you take a test online, you can use it. Okay, I had no problem with you. I can't prevent you from using it, so you might as well just make it available for everybody. So if you want to use this review on the test, go for it. So let's work this out. Any questions on that? That was under Chapter 2 page. Chapter 2 test review and exam. It's this right here, blank copy of the exam review, and I'm going to go through it. So with that, let's get started with number 1. So I'm not going to, I have extra problems here that if we come back and have time, I'll get to. I'm going to work out this document, but on over here on Smartboard. So I'm going to work it out on this page, but at yours, it'll just follow this document. Okay, it's just so you know what I'm doing. So it says first, determine the asymptotes, holes, domain, and for this graph of k of x. Okay, so the first thing, I'm going to just ask you, what would you do first if you got this problem on the test? What would you think to do first? I don't know if I have room. Start here. Question. All right, Vanessa, what were you going to say?
I think it's called solve for the X factor, the X method. Yeah.
Sure, that'd be great. I was actually thinking maybe you'd students would recommend graphing it first, but yes, X factoring is going to get everything we need. Let's graph this because I assume many students will do it that way. So if you don't mind reading off what the equation was, it was k of x equals
x squared minus 2x minus 63 over x squared minus 6x minus 27.
Okay, so if we look at this graph, we can determine a few asymptotes. Now remember, asymptotes are basically where the graph approaches but never actually equals. You can see that this graph gets really, really flat, and that's going to be an asymptote, and it gets really, really vertical. That's going to be an asymptote. So if I look vertically, I can see that it's this line right here, which is x value of -3. It looks like there's going to be an asymptote at x equals -3 that's vertical, and a horizontal one when y equals 1. You see where I'm getting these from? Let me type it in so you can see better. When y equals 1, it looks like there's an asymptote to me. And there also, whoops, y equals 1. And there also appears to be another one. I don't know why it's not letting me copy that. When x equals,
X and y, right?
pardon me?
Asymptotes can go on x and y or just on x? Or just intersecting y?
They can go both ways. They can intersect either. So I have these two on here. Let me get these. I want to make these lines dotted so we can see clearly where I'm talking about. Those asymptotes right here. You see how they divide up the graph? And so this vertical one crosses the x-axis. So you would call it x equals -3. And there's a y, or this horizontal one cuts to the y-axis at 1. And so those two would be asymptotes. So I'm going to go ahead and write that down. For asymptotes, we have, so this graph cuts through at -3. and 1. So it's kind of like that. So we had that asymptote at x equals -3. So when x was -3, it cut through, and when y was 1, it cut through. That's an asymptote, and so is x equals -3. That's an asymptote. So we've done that part. To look for holes, if you're going to look for holes using technology, this is where Vanessa said we need to x factor, because algebraically you'd find this from x factoring, which I'll do in a second. But a hole will show up if you look at the table. You look for undefined values. So -3, the x value of -3 is undefined, but that's the vertical asymptote. There's going to be another one in here. I'm going to find it real quick. I'm just typing in x values until I find. There it is. You see at 9 how it says undefined, x equals 9 on my graph. If I look over here at 9, it should have an open circle if I get perfectly there. Yeah, there it is. You see how it went open circle? That's a hole or a removable discontinuity. So we're going to have a hole at x equals 9. I know this graph doesn't actually get there, but if we continued on, this is 1, 2, 3, 4, 5. If we continued on, whenever we get to 9, it would be a hole and then keep going like that. So the hole's at x equals 9. I'm going to put that down. So where's the algebra?
What if there's more than one? Because I saw one at -3.
Okay, -3 was this one, the vertical. This problem will only have 2 because it's only has a power of 2 on the denominator. They come from dividing by 0. So here's the algebra. If you want to find this by algebra, I'm going to kind of, well, I'll work on the side. What you do is you x factor. So on the top, I want to say A, B, and C. My A times C is 1 times -63, which I get -63 there. And my B is -2. That's what goes on the bottom. So factors of 63 that have a difference in -2. I know because of the negatives, I got to have negative in here. Would it be a 1 and 63? 3 and 21? I'm just going to jump to it. A 7 and a 9? Yeah, it'd be a 7 and a 9. 7 times 9 is 63. Now, what makes it be a -2?
-7.
Okay, so 9 minus 7 is a -2?
No.
That would be the other way. It would be 7 minus 9. And so on our problem here, what I would have is on the top, k of x would equal, I say in the top, in the numerator, x plus 7 times x minus 9 over, in the denominator, if I did this x method, I'd be looking for factors of -27 that add up to -6. So is it 1 and 27, 3 and 9? It's going to be 3 and 9. Just jump to it. What makes it be a -6? 9 minus 3 or 3 minus 9?
-9.
Minus 9. Good. And so here's where the hole comes from. The hole comes from whenever you cross out a factor. You see how the x minus 9? That's going to be the hole or the removable. You could also call it removable discontinuity. Removable, because we removed it. And so that's why it was x equals 9, because inside lies. And if you want to know the y value, you'd plug that in. So this as a point would be 9, comma, you just plug in the 9 there. So it'd be like 9 plus 7 over 9 minus 3, which I think is 16 over 6. You could reduce that to 8/3. That would be the point right there. It would be 9, comma, 8/3. That would be the hole. So that's how you find that holes. The domain are any values that were on the denominator that x cannot equal. So the domain here would be that x cannot equal this 3. I'm sorry, I made a mistake. That was supposed to be a +3 right there. It was a +3. X cannot equal -3 because inside lies. So it becomes a -3. It's this one. X cannot equal that value. Nor can x equal +9. This would be my domain. All right, so that was number 1. Again, I showed you could do this from the graph. I graphed it and got the asymptotes right away. We got the horizontal, the vertical. The way I got the hole is I just started plugging in values because I knew there had to be 2 of them. If you're going to use graphing, you need to keep that in mind that whatever the power is on bottom, that's how many undefined spots you should have. So we had one at -3, and I just kept putting in values until I found one. And I could have kept putting in negatives, but I just knew it wasn't going to be that way. I knew it was going to be on the positive side. You might not know that, but I did. So that's why I just went that way. On a test, you could plug in the multiple choice answers and see which ones are undefined. So that's the way of using your graph. All right, let's move on to number 2. Otherwise, we're not going to have time to do all this. It says find the roots and extrema of the following equations. All right. What does roots mean? What's another name for roots?
Zeros.
Zeros. That's really what I'm looking for there. Where it crosses the x-axis. X-intercepts is another name you can call it. X-intercepts. Okay. So if I got to find the x-intercepts and extrema, that's like maxes and minimums. Or you could call it terms of the following equation. Let's graph it and see what we have. So x to the 4th, we'll go over to Desmos. Clear this out. X to the 4th. I can't remember if they called it f of x or what they called it. Whoa, what did I do there? Fx. There we go. What comes next?
X to the 4th minus 2x cubed plus 5x squared minus 24x.
All right, so when we look at this problem, how many zeros do you see? How many times does it cross the x-axis?
X-axis.
Yeah.
2 times.
2 times. It crosses at 0. You're looking at the x value. That's all I got to find. Is so 0 and 3. So we have roots at x equals 0 and x equals 3. Those 2 spots is where we have roots. And the extrema occurs when x equals, extrema is turns in the graph. This one, 1.874. What was it, 1.874? Okay, I think it's 1.874. That's where the extrema that's where it's found there. I can zoom out and make sure there's no other turns in this graph. Let's make sure when I zoom out, do you see any more turns in the graph? I don't. It seems like it's just a straight up parabola. So that would be the graph. Okay, different question now on part B. It says, given this equation where A, B, C, D, E, F, G are real numbers, how many roots and extrema are there in this problem? So now I don't even have numbers, so I can't graph it. I just got to go off of knowledge. How many, I should say total zeros. How many total zeros will this have? Very good. Total zeros, 6. I didn't give enough instructions here. I just realized that. I need to add instructions. So this one should be saying how many total zeros? Why'd you get 6? Because your highest power is 6. Perfect. How many turns could it have? Possible extrema. How many possible turns could it have? 5. Very good, Jose. Answer is 5. And if you just think about it, a graph that's to the 1 power, like y equals x, will not turn. It just goes through. So you can have 1 0 without a turn. As soon as the graph has 2 zeros, if a graph's going to have 2 zeros, what has to happen? If it's going to cross it a second time, the graph has to turn. So it's always 1 less turn than zeros. So if you're going to have 3 zeros, for 3 zeros to occur, the graph would have to turn a minimum of 2 times. That's right. So 1, 2, 3 zeros, you'd have to have 2 turns on the graph. All right, so all that came off of the degree. That's what you call that, the degree. Degree equals 6. And so that means 6 total zeros. They might not all be real. Like we saw in this problem, how many zeros could this have? Let me put that on there. How many total zeros could this one have had?
4.
This one had 4. It only had 2 real. So if it only had 2 real, how do we get to 4? It's not zoom out, a good thought. If they're not real,
Imaginary.
you could have, they're 2 imaginary. So on this one, they were 2 real. So since we're supposed to have 4, but we only see 2 of them, that means the other 2 mathematically would be imaginary. If we solve the quadratic formula, we find out that 2 are imaginary on this problem. Not that that was part of the instructions, I'm just throwing it in so that you remember it. Because at some point in time, that might come up. It might not be number 2, but it'll probably come up throughout the test somewhere. So there's number 2. Let's go on to number 3. It says find the domain and range of this problem. Okay, so I'm going to help give you the key. Remember with domain, I'm going to do the algebra first this time. We'll look at the graph in a second, but I'm going to do the algebra first this time. There's a rule with domain. What is it? The 2 things that we're looking for domain. There's 2 rules that you cannot do in math.
Can't divide by 0.
Cannot divide by 0. Good.
Can't divide square root.
Uh,
Square root.
You're on the right track.
Negative square.
Someone on Zoom, can you clarify? What's the other one with the square root?
You can't take the square root of a negative number.
Very good, Journey. All right, so on this problem, that's what we're looking at. So as you look at the problem, do you see any division?
Yes.
Yes.
X squared.
Yeah. So we would say you take the denominator and say x squared cannot equal 0. We have to solve for x. This is for domain, what I'm doing right now. Obviously, it's x values. How do you get rid of a square?
Square root.
Square root. What's the rule anytime you add a square root that's not originally there?
We have both sides.
Okay, mathematically, you always do anything. Time you do something, you always have to do it on both sides. But there's another rule. Whenever you add a square
Add
root,
the plus and the minus in front of it.
a plus and minus. So we'd say x cannot equal positive and negative. Square root of 0 is 0. And so this is a weird problem that 0 is neither positive nor negative. So this one I can actually take away the plus minus because 0 is just always 0. It's not positive, it's not negative. That's my domain right there. It's all reals except for 0. Now the range, I don't have any good tricks. But I can tell you the graph overall is going to go built off of this one. So let's see what it looks like. Check that. No, it's overall going to look like this. This is a higher power. That's whenever you do what's the graph going to look like, it's going to look like this one here. It's going to overall look like a line, but it's going to have a break in the middle at 0. How do I know that? Because this power 1 is bigger. Whenever you do which power is bigger for graphing, if it's in the denominator, you treat it as if it's negative. So 1 is bigger than -2. This one should look like a line graph, but it'll have a break at 0. Now you don't have to know that, which means the range is probably going to be pretty close to all reals. There might be 1 break in there, but I'm going to assume it's all zeros. Excuse me. It's going to be all reals except for 0. That's going to be my guess. We'll see. The equation was 2 divided by x squared plus 5x.
Yes.
No, it looks like it is all reals. So when I look at the graph, there is a break. There's 2 pieces here, and you can check the table. A table is a great check on domain. And at 0, did you see how it says undefined?
Yeah.
That means it does not hit 0, that graph is in fact broken apart there. So it's the domain here is everything but 0. That's why we said x does not equal 0. But for my range, you see how the graph goes forever down and it goes forever up? That means it's all reals. And what I was talking about a second ago is this graph would model, it had the same overall graph as y equals 5x, because that was a greater power. Notice, you see how these, like the 5x, how it overlaps, it just doesn't have that middle portion?
Yeah.
That's what we talked about before with leading term. If you remember that lesson when I talked about leading term, that's what a leading term does. Since the power of 5x, that's a power of 1, is greater than, you treat this as a power of -2. If you're like, wait, why is it a power -2? I'll show you. Because this is exactly the same graph as if you did this, power -2 like that. It's still the same picture. So a denominator power is the same thing as no denominator but a negative power. So since power 1's bigger, it's going to match this as for its in behavior, its overall shape of its graph. It just it comes from this part, dividing by 0 adds the break. Yep. So I can make the graph look much the same. this one was 2 divided by x squared. You'll notice that I could have done minus 2 divided by x to the 4th, and the graph would still look, well, no, never mind, that broke that way. I thought it would break up still, sorry. You'll notice these are very similar. So honestly, this didn't change the shape of the graph very much, other than to add the middle section, but it doesn't do much on the graph at all. That's why this one is so similar to this one, just doesn't have the middle break. So the leading term does not tell you about the middle, but it does tell you at the ends of the graph. So saying all that, did we answer the problem? No, not yet. Domain we got as being x does not equal 0. The range was all reals. So it could look like that, or you could write it from negative infinity to positive infinity. That's number 3. Again, if you're looking at a multiple choice test, you could just type in on the table the x values that you see and just check. Does it say undefined or is it a number? All right, number 4. Given this function, mx equals x cubed, graph and describe the effects of each of the following transformations on the graph of f, or on m, sorry, Abbott, m. Okay, so first, there were 2 rules with transformations. With transformations, this is lesson 1.5. I gave you 2 rules. I don't know if you remember this, but the rules were, first, HIVO. What did HIVO stand for? It's an acronym.
Horizontal inside, vertical outside.
Very good, Journey. So horizontal will occur on the inside. So when you look at this, the horizontal pieces are here. The vertical occurs on the outside. Secondly, it's that inside lies. Also said X's lie, Y's tell the truth, Y's tell the truth. Inside lies, outside's truth. Okay. Now those are just the rules. When I come look at this problem, I see 4 transformations. This one's the first transformation. What does a negative do to a graph? If you put a negative on, how would you assume that to change the graph? Reflects it. Yeah. So instead of it rising like a graph should be, we say rise over run. Normally it should go up. If you go negative, you're right, it slopes down, which just means instead of rising, it falls. It's a reflection. So a negative is a reflection. First and foremost, a negative is a reflection. Is that reflection going to be a vertical reflection or a horizontal reflection? This one inside or outside?
Outside.
It's outside. So if it's outside, sorry, wrong one. If it's outside, it goes with V. What does V stand for?
Vertical outside.
Yeah, it's a vertical reflection. And here's what that means. I want you to think about reflections are the tricky ones. That means the stuff that's up goes down. And I'm telling you this because I know what the multiple choice will say. It'll not say vertical reflection. It'll say reflect over which axis. Does it reflect over the, to get from up to go down? Which axis do you actually go over? The x-axis. So this is a vertical reflection. What you need to know important with this is over the x-axis. There's another door up front. There's an open door right up here. The vertical reflection over the x-axis. Oh, that's strange. Now, what's tricky about this? I'm going to ask the question. What's tricky about saying vertical reflection, but then putting it over the x-axis? Do you normally think of vertical being with the x? No, normally we think of vertical being with the y-axis. So that tricks a lot of students. That's why I wanted to draw this out. A vertical reflection actually goes a vertical reflection here. That part will not be shown in the test. What it will say is reflection over the x-axis. You just need to think through. Reflections are tricky because they don't go over the axis you think of vertical being with y, because truthfully y goes up and down. But when you talk about crossing over, you cross over, you go over the x-axis when you reflect.
So it would be a horizontal reflection and be like that, right?
If it was horizontal, it would be going left to right, and you would be going over the y-axis. That's correct, because you'd be going from right to left to right. Okay, so that's the first transformation. Let's go speed up, go to the next one. The second one is right here. What does that 2 do right there? I mean, let me ask this. Is it horizontal or vertical? Is that 2 inside or outside?
Inside.
2 is on the inside. And so if it's inside, it's
Horizontal.
horizontal. And horizontal, since it's inside, does it lie or tell the truth?
I mean, it lies.
Inside lies. I see you're trying to lie to me now. So inside lies. So it looks like it should be multiplying by 2. What it's actually going to do is divide by 2, which that means it's going to shrink the graph. So horizontal shrink, or the other word that might be used is a compression. And it'll say by factor. And the answer here is instead of multiplying by 2, you divide by 2, which means it'll be, if there's no number there, you put 1/2. So divide by 2, since there's no number on top, you just put a 1. It's a horizontal shrink or compression by factor 1/2. Now that's going to come into play on the next one. You always go left to right when we do these. This next one appears to be, well, let's just start off the normal rules. Sorry, I'll get to it in a second. Normal rules. Is that +5 inside or outside?
Inside.
Inside. So it goes horizontal. I'm going to say horizontal. Anytime you add or subtract, it's always a shift. So it's a horizontal shift. That's what adding and subtracting does. So here, reflection is a negative. Multiplication is a shrink or a stretch. A shift is if you add or subtract. But does inside lie or tell the truth?
Lie.
Lie. So instead of going +5, it goes -5, which we would normally think of being, that means left 5. But there's one more trick. You remember how we're supposed to shrink it? If you go left to right, since you're supposed to shrink it, it needs to be left 5/2. Said another way, you need to solve for x. So solving for x, 2x + 5 = 0, you'd end up with x equals -5 divided by 2. That means left 5/2. So it's left 5/2. That's a little tricky one there, is that you have to take into account that part. And finally, the last one, +4. Is that inside or outside?
Outside.
Outside. So if it's outside, it is
Vertical.
vertical. Anytime you add or subtract, it's always a shift. And outside tells
The truth.
the truth. So on the y-axis, +4 means go
Right.
up 4. It's vertical, so we need to go up 4. So these are your 4 transformations.
Wait, how come it's up for?
Because it's outside,
Oh,
so
up
it's
for
vertical.
parentheses?
Yeah, outside the parentheses, so it's vertical. So a quick way to check this is it says m's equation is x³. So here's how you can check this using Desmos. Is I'm going to say mx, not mx, I'm sorry, m of x equals x³. That's what the instruction said. Did you catch that? It said m of x is x³.
Yes.
That was the instructions. If you now type in this underneath, negative m 2x +5 +4, you can kind of see, now this one's a little bit hard to see what's happened. Let me zoom back over. You can see here was the origin, and here's now the origin. Over here, not the origin, I'm sorry, they call this inflection point. You see where the cubic graph makes this little S curve? I can see the S curve over here. Which way did it move? It moved 2 directions. Which 2 directions did it move? To the right and up? Or to the left and up?
For which one? The first one?
Yeah.
Oh, to the left.
Yeah, it went left and up. We can see it moved up 4 units. I can also see that it moved left, if I zoom in here, 2.5 units. Like there's the center right there, somewhere in there. So it moved left about 2.5. Or I can just touch it right there. You see how it went left 2.5 and up 4? That's what we said here. left, that's 2.5. 5 divided by 2 is 2.5. It went left 2.5, it went up 4. It reflected, oh, it's hard to tell on this one, the reflection, but it flipped vertically, which means this piece that's going up became this, how the right went up, now the right's going down. The left part went down, now the left part's going up. So that was the vertical reflection, and it's more narrow. That's because it was a horizontal shrink. So that's a way of at least getting the shifts right, is if you use graph like that, you could at least tell, okay, it went left and up, and you could touch it to see how much it moved left and up. It moved left 2.5, and it went up 4 units. So that's another way using calculator of getting that. All right, let's take a look at number 5. It says use the function f of x equals x squared to apply the transformations in the given order. All right, so here it is, f of x equals, and I'm going to do these, I'm going to leave some space just in case I need to move things around later. Okay, so number 1, remember the 2 rules, HIVO and inside lies, outside tells truth. Here's our 2 rules. Okay, first, translate 8 to the right. That means shift. Translate is the same thing as shift. So if I want to go right, does it need to be, is that horizontal or vertical? The word right, is that horizontal or vertical?
Vertical,
So
but on the outside it's vertical, right?
horizontal is anything dealing with the left and right. So like if you talk about the horizon, if you look outside, talk about the horizon, that means way out as you look left to right. Vertical is talking about the y-axis. So if you were to move to the right, if you're going right, that is a horizontal shift. Whereas if you went up or down, that would be a vertical shift. And I put left on here. Left is also horizontal. So when it says right, we need to go horizontal. So what does that mean? If it's horizontal, where does it need to be located? Inside or outside?
Outside.
Check the acronym.
Inside.
Horizontal needs to be inside. It needs to be inside the square root, and inside lies. So instead of going right, which we normally think is plus 8, it's going to lie. So what's the opposite of plus 8? Negative 8. So the first one, I'm going to put a minus 8 right there. Next transformation. Stretch, which is the same thing as expand. They could say expand. Vertically. All right, so I'll circle that up. So vertical, is it inside or outside? Vertical is
Outside.
outside. I have factor, that means multiply. And oh, outside tells the
True.
truth. So factor means by multiply. Since I'm doing the truth, I'm going to multiply by 4. So it's outside multiplying by 4. You could put it here, but that's not normally where we put it. We would normally put it multiplication in the front. So you'd put it right there. Now I have one more here. Reflect. The other word for that, it could be flip. So they all have like different words you could use. It's a flip across the x-axis. All right, so let's talk about this because reflections are tricky. If it goes across the x-axis, that means it's moving this way. To go across the x-axis, you're moving this way. Is that a vertical or a horizontal reflection? Which way are my arrows moving? Vertically or horizontally? Very good. They are moving vertical. So this is a vertical, or vertically, I should say, no, maybe I was right. A vertical reflection. So vertical, is it outside or inside?
Outside.
It's outside, and a vertical comes from a negative, so I just put the negative right there. All right, questions on that? All right, let's move on to number 6. This will be a third of the way. Describe the transformations on this graph. All right, so tell me, this is the third one of transformations. How many transformations do you see going from square root x to square root 7x minus 1? How many transformations have occurred?
2.
2, I agree, it's 2. So what are they? It's the 7 and the negative 1. Is that 7, would you call that inside or outside? I agree. So if it's inside, does that mean it is horizontal or vertical? Good. So I'm going to say, sorry, that's a horizontal. And if it's horizontal, it's going to lie. Anytime it looks like a multiplication. That's what it looks like, 7 times, but inside lies. So what's the opposite of multiplication? What's the opposite of multiplication? Division.
Division.
Yeah, so a division is a shrink. So this is a horizontal shrink, or you could say compression by factor. Again, you say by factor, that means multiply. But since we're dividing by 7, you say divided by 7. What do you put on the top if there's nothing to go up top?
A 1.
A 1, good, because it's kind of, here's why, just to help out. I didn't do this earlier, but it's 7 is the same thing as 7 divided by 1. And so really what you're doing is you just take the reciprocal. You do the opposite. Instead of multiplying by 7 over 1, you do the reciprocal. You multiply by 1 over 7. That's the idea there, is you just flip it. So if it helps you think 7 was multiplying, divide it, and if there's not a number, put a 1. Or you could just think of, okay, that should be 7 over 1, so just flip it. So on a problem, let's say you had 3 halves x, you would end up making it by factor 2/3. You just flip it, okay, if you see it that way. All right, now, what about that minus 1? Is that minus 1 inside or is it outside? Again, it's inside. So if it's inside, it is horizontal. Good, you did the math. It's horizontal because it's inside, and it's going to lie. By the way, anytime you add or subtract, it's always a shift or a translation. And so instead of going minus 1, it's going to go plus 1. On the x-axis, if you go plus 1, which way did you move? You go to plus 1, which way did we move?
Right.
We move right 1. So it's a shift, right 1. There's a graph. Again, you could graph these two and just compare. Oh, I almost made a mistake. Can someone correct me? What did I do wrong here? It's the tricky part with horizontal shifts. We did make it lie. I forgot to do the shrink. You know how we're supposed to shrink it? It's actually going to be right 1/7. Sorry, you have to combine that. So when you go left to right, if there's a horizontal stretch or a shrink, you have to combine that. It's always solving for x. And so this one you would add the 1 and then divide by 7. And that's why it's right 1/7. I almost screwed that up. I'm glad I mentioned that about graphing because I just thought about what's going to happen there. If we graph this to check, y equals square root x, y equals square root 7x minus 1. Notice, did it move a full unit to the right? So this is a good check. Just use your graph. Did it move a full unit to the right? There's 1 unit right there. No, it did not. If that 7 would not have been there, it would have gone 1 unit to the right. The fact that the 7's there, it shrinks it. It's 1/7 of the way. Yeah, so like that 1.43 times that by 7, we'll get basically, if you round, 1. So that was 1/7. So if you had 7 of those, it would get you all the way there. So anyways, they went 1/7 to the right. And as you can see, it's a horizontal shrink always looks like a vertical stretch as well. It's like that balloon. If you remember me using the balloon illustration earlier in the year, it's kind of like a balloon. If you squeeze the balloon horizontally, vertically, it's going to expand. That's what's happened here. It looks like it's a vertical compression. Okay, number 7. Determine whether this is continuous. If it's discontinuous, classify each discontinuity as an infinite, jump, or removable. All right, so how would y'all go about trying to solve this one if you were taking the test? Let's graph it. And so I'm going to go take this over to the graph. Jose, do you mind telling me it was f of x equals?
X squared minus x minus 6 over 3x squared plus 3x minus 18.
All right, here's the picture. Now, before I zoom out, how many breaks could this graph possibly have? 2, because I only had 2 powers in the denominator. So when I zoom out, how many breaks do you see? You see 3 pieces, but to have 3 pieces, 2 breaks. Yeah. So I have a break here and a break here. What x values does it appear that this one's breaking at right there? -3. Where does it appear to be broken here? 2. Let's check our answer. The way to check it is if you hit the little gear and you hit the table, convert to table right there. We're going to try at -3. Does it say undefined? Yes. And at 2, does it say undefined?
Yeah.
Yes. Those are our breaks. It can't have any more because it only has 2 powers on the bottom. What makes a break is a x dividing by 0, which means you go off of how many x's you have. We have x squared, so we can have 2. We found them both, -3 and 2. So our answers are x equals -3, x equals 2. What type of breaks are they? If the graph breaks and go to infinity. So no, it's discontinuous if it breaks. So it is discontinuous. What kind of discontinuities are they when they go to infinity? Are they infinite, jump, or removables? They're infinite breaks. So we call both of these infinite discontinuities. Okay, and the algebra you get by x factoring. So if you x factored these, so factors of -6, I'm doing the a times c and over b. Factors of -6 that add up to -1, they're going to be 2 minus 3. Those are my numbers. Those multiply to be -6, add to be -1. And then on the denominator, I'd be looking for factors of, 3 times -18, getting -54. Factors of -54 that add up to be 3. 6 and 9. Is that right? 6 and 9. And I need to be a -6. So when I put these together, this one has a 3. I'm gonna have to do a little extra work on that. What's gonna happen? Oh, I should have GCF'd that. Sorry. Should have GCF'd. It would have made the whole problem easier. You notice if I factored out the 3 there, this would have become a 1. This would become a -6. I could have done it just like that. Man, it would have been a whole lot easier. If I just would have GCF'd that 3 out in front. Now, if I did this, I'd get a -6. So I was about to run into problems there a second ago. And my numbers would be a +3 and a -2. Now with the GCF, sorry about that. At least I gave you the answer the first time through graphing. You'd have this. I GCF to 3 through the front. They all shared a 3 in the denominator. So if I factored out 3, I was then working with 1x minus 6. And so factoring that, that's where I got x plus 3 here and x minus 2. That's the denominator. This is the numerator. X plus 2, x minus 3. Now this is very important for you. Are these x plus 3s and x minus 3s exactly the same? Can I remove them? Can I cancel them? No, I cannot. They're not the same. So they're not removable. They're infinite. They're not the same. You see how these are not the same? So they're not removable. So they're infinite discontinuity. So if I change the problem, if I just had made this a minus, if that was a minus, the equations would have matched up perfectly. These would have become removable. I will show you. What am I trying to say? If I mathematically had made this a minus, it's going to make both of those factors cancel out, and it's going to look like it's continuous all the way across. But if I still go, why is it not, that's not accurate. Why is it not, oh, sorry, it needs to be -2 now and a +3. You can see now at -2 and +3, when I change that, or it's undefined, that means at -2, we have an open circle. That would be removable. Again, that's what removable looks like, a hole. And at +3 would now be undefined, a hole. But I changed the problem. That's not the way I originally gave you the problem. I gave it to you as a plus, so it should have been infinite breaks at those spots. Okay, so discontinuity means it breaks. Continuous means there's no breaks. It's one piece all the way across. Questions on number 7? All right, piecewise. All right, this I really need to show you how to graph. For you Zoomers especially, here's what I want you to know. I have, if you're using Power School Learning, I have a page dedicated to Desmos graphs. But in the future, I think I told you this on Thursday last week, starting after this test, I've created where you can do everything from Google Classroom. And so I'm assuming, I've heard from students, that was the feedback I got, like, hey, if you can improve something, Mr. Voorhees, the thing that would really help is use Google Classroom, because that's where all my other classes are. If you go to your Google Classroom, click first period and go classwork, right here in the daily, weekly links, not only do I have the Zoom link, attendance link, all that, I have Desmos pre-programmed graphs, and I forgot to update that for today. I'm sorry. If you go there, you can click this Desmos graphs, and one of the options I have for you is piecewise functions to help you graph that. So I'm going to click this link, and it'll open up the piecewise function. Now, how many equations do I have here? 2. That's the standard for this piecewise graph. So let's read off the top. It's negative. So it says here, step 1, first branch, negative x cubed. Okay, next, yeah, here.
Negative x cubed plus 7x plus 2.
And what did it have for the restriction? That means what x values was it for? X is less than 3. So when I come over here, I type in x is less than 3. So there's the first piece. What's the second piece?
Negative 4x over 3.
Okay, there it is. And what's its restriction?
X is greater than or equal to 3.
Okay, so here's my graph. It looks like this. So you see how easy that was? By the way, if there was a third piece, what you would have to do is you just go to step 2b right here, this optional, and you type in a third equation. But you would have to, if you follow all the way down, you have to go to step 3. You'd have to choose how many branches. The 2 is the default, piecewise with 2 branches. If there was 3, you'd have to unclick this one and turn on this one right there for 3 branches. That's how that works. But we got our picture. So that's our picture. I'm going to come back to our problem. It said graph, then describe the continuity. Okay, well, I'm not, for the sake of time, I'm not going to graph it. Here's your picture. That's what it looks like. Tell me, is that a continuous graph or is that graph broken? It's broken. What type of break do we have in this problem?
A jump point.
We have a jump. Very good. There is a jump in this graph. And I'm going to look to see if there's any other breaks. I don't see any other types of breaks. Remember, breaks happen when you divide by an x. I don't see any divisions of x. I see a division of 3, but not a division of x. So that's going to be the only break is this one jump. So there's our graph. We're going to say it's a jump discontinuity. Jump discontinuity. And the jump occurs on piecewise at this value right there. Whoa, that's a typo. It should just say x is greater than or equal to 3. So there's jump discontinuity at x equals 3. That's where the graph jumps, is that number. On yours, did I have 3x or did it actually just say 3?
For the x is greater than or equal to?
Yeah.
It's just a 3.
Okay, so I've updated that one. I just haven't updated this version. Okay, so this has a jump discontinuity at 3. And if you're not sure, how do you know that from a graph? You just look at where they jump from one place to another. It jumped at, why did that one stop there? It jumped it was supposed to be 3. I don't know. I need to check this. I might have a little math here. I might have to update this site. Not exactly sure why. I don't know. I'll figure that out later. But it's at 3. It's at this value. That's where the jump first. Let's go to number 9. It says use the function here to evaluate the limits. And now limits is talking about the behavior. It's talking about with asymptotes, things of that nature, at -7 divided by 5. Okay, so let's go graph this first so we can figure out our limits. So I'm going to graph this equation. I'm going to go back to the normal Desmos I've had going this whole time. Where is it? There it is. All right, so the equation was f of x equals, what do you have in the numerator?
8x minus 1 over 5x equals 7.
There you go. And so here, and it wants to know the limits when x equals, was it negative?
-7 over 5.
Okay, so I want you to notice, and I'll change it to where this is a dotted line. That's where it wants to know the limits, is this part of the graph. So what's happening, remember with limits, you have one of 4 options. It's either rising forever, falling forever, getting flat for forever, or it's coming to a point. What's the piece doing on the left side of the graph? Is it, so on the left side of the dotted line, I'm sorry, it's rising, good. So your answer would be this. You'd always start, all the answer choices will have this option. You'll say -7/5 with a minus. That just means the left side of this asymptote. You would all have this. What you'd be looking for is the one that has the symbol for rising. What's the symbol for rising? No, that's a good thought. It's not a plus. Meaning
Is it
it
a
goes
positive
forever.
infinity?
Joshua, what'd you say?
Is it a positive infinity?
A positive infinity. That's right. They'll say positive infinity. That means rising forever. This limit down here would look this way. All the answer choices would have this attached to them, -7 over 5 with a plus. What that means, what that little plus means, is you're looking on the right side of the break. So here's the break. On the right side of it, what's the graph doing? Is it rising? Is it falling? Is it getting flat? Or is it coming to a point? Yeah, it is negative infinity. That's the answer. Why is it negative infinity? What's the graph doing? It's falling. So it'd be negative infinity. So these would be the answers right there. So number 9. All right, number 10. Write a polynomial function with degree of 4 with real coefficients in standard form that has these zeros. Oh man, this one's unfortunate, but I got a shortcut for you here. All the answer choices, if you graph them, they need to hit, it says degree of 4. That means I need to have 4 powers of x's. And it needs to hit at the real zeros of 3 and -1. Is a 1 plus 5i a real 0 or an imaginary 0? It's imaginary. We know that because of the I. The I means imaginary. So it won't hit there. So the actual answer needs to hit at 3 and -1. So if you have multiple choice, you can graph and first off eliminate anything that does not hit at 3 and -1. That's the first thing you can do. Now, I'm going to just go through the algebra because we don't have multiple choice here. So here's what I know first. Is this polynomial function has to have 4 zeros, a degree of 4. That means I have 4 parentheses with an x in them. I will have 4 different ones. Now, they gave me 3 of the zeros. They gave me x equals 3, -1, and 1 plus 5i. So when I put these in, inside lies, so this is going to become x minus 3. Because to solve, this is solved right now. If you want to get the 3 the other side, you have to subtract it. So you'd have x minus 3 is 1 parentheses. The -1, if you moved it across and made it a lie, it would become a positive 1. And the last 0 that they gave me, it's a 1 plus 5i, which means If I subtract it, the 1 becomes a negative 1. The positive 5i becomes a negative 5i. Now, how do I get my other 0? The answer is that imaginaries always come in pairs. If you have a 1 plus 5i, you're also going to have a 1 minus 5i. So I need to have a plus and a minus 5i. So what does that mean for the 0? The only thing that's going to change, the 1 is still going to become a negative 1. But the negative 5i is going to become a positive 5i. So this is the only part that's different. Now to solve this, to actually get your answer, so this is the factored form. That's it in factored form. But this instruction says get it in standard form. You're going to have to distribute all this out. I'm going to do the real with the real and the imaginary with the imaginary. So first, the real with the real. What's x times x? Let me get that arrow a little closer. What's x times x?
X squared.
X squared. And then I have x times 1.
X plus 1.
It's multiplying, so it'd just be plus 1x. And then I'm foiling right now is what I'm doing. Negative 3 times x. Negative 3x. And negative 3 times positive 1. Negative 3. Because I do have 1 negative. Yep, there it is. So right now when I multiplied those two out, this is what I got. This is the front two. When I multiplied, I got this. Now we're going to multiply the back two, the imaginaries together. So let's see what we get. X times x. X squared. X times negative 1.
Negative minus x.
Minus x. X times positive 5i is going to be positive 5ix. Okay, now I'm going to switch colors. Negative 1 times x. Negative x. Negative 1 times negative 1 is a positive 1. Two negatives cancel. And a negative 1 times 5i is negative 5i. Get a different color here, one I haven't used yet. So now negative 5i times x, negative 5ix. Negative 5i times negative 1 is a positive 5i. And if I don't run out of room, last one, negative 5i times positive 5i is negative 25i squared. And now I'm going to close this parenthesis. Ugh. So there it is. There was the front foil. This is the back foil. Quick note on imaginaries, the i's should cancel. You see how I have a positive ix right here? I have a positive 5ix and a negative 5ix. A positive 5ix minus a 5ix cancel. Here I have a negative 5i. Over here I have a positive 5i. Guess what happens to those? They cancel. I squared, as a reminder, is equal to negative 1. So a negative 25 I squared is equal to a negative 25 times a negative 1, which that is equal to a positive 25. So when I combine my like terms, here's what's going to happen. On this front parenthesis, this is going to become x squared. These two are going to combine together. I have a plus x minus 3x. That's going to be a minus 2x minus 3. And over here, I'm going to have an x squared. Now notice I still have this right here left over, a minus 5, a minus x, and a minus x. They're both negative, so they don't cancel each other. So that just becomes a minus 2x. And then I have a plus 1, and that's going to be, that right there is the same thing as a plus 25, positive 25. That's what I got right there. So 1 plus 25 is going to be 26. So finally, the longest problem ever, to get the answer, we we need to multiply this out one more time. So again, there is a shorter way of doing this. And so this is the standard form. What we're about to get is going to be our answer. Is I'm going to have x squared, or x squared times x squared is not x squared. X squared times x squared is x to the 4th power. X squared minus 2x minus 2x cubed. X squared times 26 is a 26x squared. Switch colors. Negative 2x times x squared. Let's go in order. That'd be a negative 2x cubed. Negative 2x times a negative 2x is a plus 4x squared. And a negative 2x times a positive 26 is a negative 52x. Last term, last distribution, negative 3 times x squared is negative 3x squared. Your hand cramping up yet? A negative 3 times a negative 2x is a positive 6x squared. And a negative 3, not x squared, I'm sorry, just x. Negative 3 times a positive 26 is a negative 78, I believe. So I can combine like terms here to get a final answer. So f of x would equal x to the 4th. I see I have negative 2x cubed, a negative 2x cubed, that's negative 4x cubed. And that's it, so negative 4x cubed. I have a 26x squared, 4 more x squared, that's 30x squared, minus 3 is plus 27x squared. And let's see, negative 52 plus 6 x's is a minus 46x, and then minus 78. That would be my equation if we did that correctly. And so now that I know the answer, I'll show you what I would recommend on the test is if you had all these different equations, graph and see which one has the right zero. So I'm going to come back over here to my graph. And so did you get that answer written down?
Yeah.
Okay, so it's f of x equaled x to the 4th minus 4x cubed. That's what I remember. Okay.
Plus 27x squared minus 46x minus 78.
Okay, you see how it hits at negative 1 and 3? Were we supposed to have zeros at 3 and negative 1? Yes. So we graphed and we saw there's only 2 real zeros. There's no other real zeros. We have negative 1 and 3. And the quicker way is, let's say there's 2 answer choices, is if you do synthetic, from there, if you did synthetic on this, you would get down to where you could do quadratic formula and get that. So this is probably the quicker way is to, instead of doing all this math, would just be to do synthetic. And I could do that here, but we might run out of time. But you would do synthetic where you take those zeros of 1, negative 3, like first graph it, find out if there's 2 choice, like maybe there's only 1 choice and you got your answer. But if there's more, do your synthetic, and then what's left over, do quadratic formula, and you should get 1 plus 5i as your answer. Okay, I'll see if it comes up synthetic later. Okay, this one, we can do this one a lot faster. It says given the degree 5, so that means there needs to be 5 zeros. With real coefficients here, find the other missing roots. So this time I don't have to actually solve the whole problem. We just find the missing roots. So remember, if there's an imaginary, it's always going to have a pair. So if they gave me 3, 2 minus I, and they gave me 6 plus I. But what can you tell me about any time you have an imaginary?
It's a plus or minus.
It needs to be a plus or minus. So I should have a 2 plus I, and I should have a 6 minus I. So the missing roots would be x equals 2 plus I and 6 minus I. Those are, let me put a comma. Those are the missing roots. And that right there is your answer. Those are the missing roots. You just have to have a plus and negative I. Nice to have a quick problem after that long problem. Number 12. Here's synthetic. Yes, I like this. I love synthetic. This one I like, it's kind of like a game here to figure out what the number has to be. It says find k so that the quotient has a 0 remainder. That means that r of x equals 0. So start off with me. What am I actually going to say x equals? Does x equal -6 here?
Yes.
No.
No.
Inside lies.
No.
So it's not solved for x. So that just basically, if it's not solved for x, consider it inside. What is x going to equal there if you solve for x? You said x minus 6 equals 0. What would x equal?
+6.
6. So that means we need to divide by 6 here. My coefficients, I have 1x to the 4th, -8x cubed, k for x squared, +15 for the x, and -18. You cool with that? I'm going to draw my line across. Now, they gave me a very important piece of information. And this is where I think some students struggle in this problem, is if they don't read the instructions here, or if it doesn't trigger what this means. Where is a remainder found on synthetic? At the end. That means I need to get a 0 right here. Okay, that's a key piece of information. So let's go through solving this. 1 falls down, and so what is 1 times 6? Because we do mama, we multiply, then we add, then we multiply, then we add. So 1 times 6 is 6. -8 plus 6, because I'm adding, becomes -2. Now I multiply. 6 times -2 is -12. Okay, now I have a problem because I have a k here. So this is why I say this problem is kind of a game. So I'm going to stop there. I'm going to pause. I'm going to come over here. Now, if you had a 0 remainder, you could know for a fact what number has to be right there. It has to be a +18. Now, how did you know that, Jose? Okay, great. So if I had a +18, that means the number that was right here multiplied with 6 and gave me 18. So now if I'm going backwards, instead of doing mama, it's kind of like I'm going to subtract, if you will, or add, subtract, divide, add, subtract, divide. If I'm going backwards, it's kind of like I'm going add, divide, and I could say subtract. It's just SD. SD is going to be weird. I'm going to do the opposite. So you could call it subtract. It's easier just to think of it this way. So it's kind of like going like this when you go backwards. So we said +18. That was the adding part. That's what I had to do there. So the next part would be dividing. What is 18 divided by 6? 3. And so now, what number, and truthfully, like I said, it's kind of like subtract here. What number would I need to subtract from 15 to get 3? Or said another way, if you took 15 and you subtracted 3, what number would you get? 12. So the number has to be a 12. Does it need to be a +12 or a -12 to go from 15 to 3? So 15 plus 12 is 3? Minus. So it's going to be 15 minus 12 is 3. So now we know this number. So now I'm back to dividing. What is -12 divided by 6? 2. +2 or -2? Needs to be a -2. So this number right here is going to be a -2. -2 times 6 would be -12. All right, so now I get to the problem. Some number minus 12 gives me -2. I could also say, since it's some number minus 12 equals -2, you could also add the 12 over here. What is -2 plus 12?
-14.
Nope.
+14.
-2 plus 12. If you look at it this way, if I move this across the equal sign, I'm hearing 10. Let's just say we thought it was 14. Let's check. Let's just say we thought it was 14. What's 14 minus 12? Is that -2? No, so that one.
Positive.
What if we tried 10 now? What is 10 minus 12? -2. And now we get 0 all the way across. So the number is 10. Okay, so the key when you do this, play this game, is you're doing the opposite steps. So let me show you why I said add, divide. It's because basically you do this. Right now I had -18 plus some number. Let me erase, and I'm going to show you why I said that. Do it all over again from here. The line is kind of like the equal sign. So right now it's kind of like negative 18 plus some number, I'll just call it x. It's going to equal 0. And so what you do is you add it across. You always do the opposite. So x became positive 18 when I added across. That's why I got positive 18. Now you would divide. We got 3. So then I would do the same thing here. I would say 15 plus some number. 15 plus some number is going to equal 3. And so you would subtract the 15 across and get negative 12. To solve for x, you would subtract the 15. You do opposite. And so that's where you get the negative 12. So I'm still kind of doing adding and subtracting. That's why I left it like that. But then you would divide. Negative 12 divided by 6 is negative 2. So this time I would have k minus 12 equals negative 2. And so you would add 12 to both sides. Whoops. 12 to get your answer. And so we have k equals positive 10. And that's how I got that. All right, looking at the clock, we got 19 minutes. We got to do 1/3 of the test left. Jessica invites some friends to a Cowboys game. She purchases a suite at the stadium for $50. This is back before COVID when I made this one. I don't know if they still let you rent a suite for $1,500. Oh my goodness! And she also orders $250 Pizza Hut package. 3 other family members already got tickets to the game, but joined for the pizza. If the prices were divided evenly between Jessica and her friends, and the cost was $57.58 per person, how many friends did Jessica invite to the game? So the way you figure out average cost, an average comes this way. You have the total divided by the number of people gives you your average. Y'all remember that math from when you were younger? The total divided by the people gives you your average. Okay, so what's the total for the Cowboys suite?
1,500.
That's right, 1,500. That's the total. Now, who is going to this game? Jessica and her friends. And so on this part, we're looking for friends. So I'm going to call x equals friends.
So x would be greater than 3 because it has 3 other family members.
So it's going to be, for the game, it's going to be Jessica and her friends divide this cost. I think the prices are divided. There it is. So we'll get to the family in a second. So right now it's Jessica, who's one person, plus friends. So Jessica equals one person. Let me write that over here too. She's one person, so it's Jessica plus friends. I should just do here. Jess, I'm going to abbreviate. Jess plus friends. They pay for that. Okay, now there's a second cost. What's the second cost?
Wait, never mind. The pizza.
Pizza, which is $2.50. Now, how many people eat pizza?
3 or 4 plus Jessica. Or
So,
3 plus Jessica.
Does Jessica eat pizza?
Yes.
And does her friends eat the pizza? It's assumed. So we're going to say Jess plus friends, so 1 plus x. But there's 3 other people who also eat. I'm just going to do plus 3. So could I change it to x plus 4? Yes, I could. But I'm going to make it this way so I can see easier. This is Jess plus friends plus family. Jess plus friends plus family. And how much do they spend in total?
250.
No, that's how much the pizza was. It was $57.58. That's your equation right there. So we come over to our graph. I'm going to end up separating this, but for right now, I'm going to write it out as one equation. 1,500 over 1 plus x. And by the way, you could do x plus 1, doesn't change anything. Plus the $250 pizza, which is eaten by Jess, plus her friends, plus 3 family members. And this ended up for being $57.58 average price. Okay, as I look at this, the solutions are always the x-intercepts. I see two solutions. One of them's negative. Are you allowed to have negative friends? I made the joke the other day, only in personality, but not actually by counting. So this is how many friends we have. If I zoom in, you can tell I have 29 friends go to this suite. And I made a big problem. It's a suite. So it'd be 29 friends is the answer. Because that's where the x intersects on the positive side. Now, how can you do that another way without zooming in on the calculator? If you can't see the number very easily, you can divide the equation up. Come on, what happened to my computer? And you can do y equals the left side and y equals the right side, like that. You go up to the y value of 5758, and you should have a solution right there. And then the calculator will tell you exactly how many people it's got to be. The answer is 29 people. When that rounds, it'd be 29 people. So the math didn't work out exactly perfect, but with money, we round it. That's why it's a little bit off. But yeah, it would be 29 people. Okay, that you could do it that way as well. All right, number 14. If Jessica decides she needs keep the cost below $50 per person, at least how many people must she invite? So this means we're using the same equation I just did, but this is the inequality that we did last class. So I'm going to write the same equation. And if I wanted to, I just want to make sure you're aware of this. If I wanted to simplify this, what is 1 plus x plus 3 the same thing as?
4 plus x.
You could say 4 plus x. Yep. If I want to keep it below $50 a person, does that mean that the person could spend more than 50 or less than 50? Less than 50.
Less than 50.
So you'd put it this way. If you want to keep the cost below $50 a person, you put this inequality in. And now let's see how many people we'd have to invite. So I'm going to come back to my problem, and all I'm going to change is I'm going to make this be a less than 50. And so again, it's real world, so we ignore the negative parts. This is going to be our solution here. And I'm going to change this to a 50. So we can figure out how many. We need to have at least 33.6 friends. Can you have a 0.6 of a friend? No. So to have more, to be in this side, you'd have to get up until at least 34 friends. So since the value would cross at 33.6, I'm going to say at least 34 friends. That would get me into the shaded region. Okay, different question that doesn't come up really on this problem, but I'm going to make sure you understand this. Why am I not including this portion of the shaded graph, the left side? Why do I not look at the left side? It's negative. On real worlds, do you pay attention to anything outside the first quadrant? Only if it's money might you, if it's like owing money. But other than that, that wasn't about this problem. It wasn't about owing people money. You don't pay attention to these quadrants. You only pay attention to the first quadrant.
If it wasn't about owing money, you would pay attention to the bottom quadrant.
You would, just these two. Still not negatives on the left side. Yep, good call there. All right, we got 4 left. I got 11 minutes for them. Jamie, Priya, and Paul can paint a room together in 2 hours. If Priya does the job alone, she can paint the room in 5 hours. If Paul works alone, he can paint the room in 6 hours. If Jamie works alone, how long would it take her to paint the room? So this is the idea of the problem. When we talk about speed in physics, you learn that speed is distance divided by time. What's weird on this problem is we're not talking about running. So we're not talking physics per se, we're talking about painting a house. So the thing that's been substituted is not speed. We still have speed. We're talking about how fast and all that. We still have speed. We still have time. What's changed is distance. And it's been replaced with houses. How many houses you paint, if you will. So there's 3 people. We'll call them Jamie, Priya, and Paul. It says Jamie can, when they're working together, they can paint 1 house in 2 hours. There's that part of the equation. When they work together, that means add them all up. It says, if Priya does the job alone, she can paint the room in 5 hours. Or I said house, I'm sorry. This isn't house, this is rooms. She can paint one room in 5 hours. If Paul works alone, he can paint one room in 6 hours. If Jamie works alone, how long would it take her to paint the room? So one room, do we know how long it takes her? So what do you put for an unknown?
Mister, did you put it under the wrong name?
I don't think so. Paul works alone, he's 1 in 6. Jamie works alone. Yeah, I did, sorry. Thank you. Just making sure you're paying attention. Way to go, Vanessa. That's Mr. Voorhees' excuse
It
for.
wasn't me. It was someone else.
Oh, whoever it was, well, thank you. Again, I was just making sure you're paying attention too. Mr. Voorhees is never wrong. He's just checking to see if you're paying attention. That's all it ever is. All right? And not the excuse your authorities always make. That's what I'm doing. Okay, so our equations was 1 over x plus 1 over 5 plus 1 over 6 has to equal 1 over 2. Is that correct? All right, I see the answer is here. It's that spot, but if you're not sure, you can always divide up the equation. You can do the left side of the equation equals the right side. And where they intersect is the answer. So where all these graphs intersect, right there is the answer. I'm not paying attention to anything like that. It would take her, the x value is the answer, 7.5 hours. 7.5 hours is the solution. Now I can show you the algebra. Do y'all want to see the algebra on these? I didn't even do it on the last problems. The algebra is the same on all these. You multiply by the denominators to solve these. So if you wanted to just go through and do the math, you look at the factors that are in the denominator, which in this case are x, 5, 6, and it looks like a 2. However, 6 is the same thing as 2 times 3. So I'm okay if I just multiply by this, x, 5, and 6, every denominator will cancel. So if I multiply everything by x, 5, and 6, that's the same thing as multiplying by 30x. So this is how you'd solve this problem, is you'd say 30x times 1 over x plus 30x times 1 over 5 plus 30x times 1 over 6 equals 30x times 1 over 2. You go through it this way, and you realize in each problem something cancels out. So I'd have 30 plus here, that 5 and 5 cancels, and you get left with 6 plus 6x plus here 6 goes into 35 times. So equals 5x equals here 2 goes into 30 15 times, 15x. And to solve this, I'm going to subtract 6x, I'm going to subtract 5x, which is basically subtracting 11x. Minus 6 minus 5 is the same thing as minus 11. I'm going fast because I doubt any of y'all will use this technique. So I'm getting 40x there, 4x, and then you divide by 4. 30 over 4 is the same thing as 7.5. And that's how you get that. Okay, let's finish off this problem. 16. It says apply the leading term test to determine and write the end behavior of the function. So the leading term test is what the graph will resemble in power. You cannot find that readily from factored form. If you remember, the things that factored form finds you, factored form finds you the zeros and the multiplicity. We talked about this earlier, this chapter. What standard form finds you, which we do not have here, standard form gives you the leading term and the y-intercept. So if you're going to find the leading term test from factored form, you have to multiply anything that has an x together. So the leading term, I'll just do LT, will equal x times 4x times x squared. Anything that has an x, you multiply through. So x times 4x times x squared, I'll have a total of how many x's? I see right now it looks like 3, but one of them squared. So it'll be a total of 4 x's. So this is 4x to the 4th. If it's 4x to the 4th, what that means for my limits is this graph, it's going to look like a parabola because it's to the 4th power. It's going to look like a parabola going up. So this part would say that the limit as I go left, and the limit as I go right. That's what we're going to try to fill in here. What happens when you go left? Does the graph rise, fall, flat, or come to a point? As we go left. And by the way, you could graph all this. It's probably the easiest way just to graph the whole thing. But as we go left, it looks like to me the graph rises. So it'd be a positive infinity. And as I go right, the graph will also rise. Part B determines zeros and multiplicity. So that's what the factor form finds. So I have zeros. I have one at 0 here. Now inside lies. So instead of it being a negative 5, it'll be a positive 5 divided by 4 if you solve that. And you would also have a negative 3. And that negative 3, since it's squared, would be multiplicity of 2. Again, you could graph this and you would see these zeros, but the multiplicity of 2 is because it's squared. Part C, you just plug in negative 1. F of negative 1 would equal negative 1 times 4 times negative 1 minus 5 times negative 1 plus 3 squared. Again, you could graph this in a calculator and figure out what that value is, but I'll just do it real quick. That's going to be negative 4 minus 5. That's going to be negative 1 times this becomes negative 9. And this becomes positive 2 cubed is 8. 2 negatives make a positive. That's going to be positive 72. And then you graph it. Again, I would just go to the calculator and graph that. All this can be found from the calculator. There's our graph. You can see the zeros. Negative 3, 0. 5 divided by 4 is 1.25. That is 5 divided by 4. 1.25. So there's the zeros. Multiplicity always looks like a parabola or S-curve on the spot. That's why that has a multiplicity of 2 right there. That's part B. It says, what is f of negative 1? If you type in the whole equation like that, all you have to do is type f negative 1, and we got a 36. Did I type in something wrong here? I just did bad math then. 2 cubed is 8, right? Negative 4 minus 5, negative 9. What did I do wrong? Negative 1, negative 4 minus 5 minus negative 9. That's a positive 9. Negative 1, 2. Oh, I cubed it. It's not a cube here. It's a square. That should have been a 4. That's why. But an 8. That should have been a 4, and that would have given us 36. There we go. Okay, and you can look at the graph. That's what it looks like. So the calculator is more reliable than me anyways. That's for sure. Okay, we got one problem left. What do we got? 2 problems. Which one do you want me to work? The box problem or long division? I'm going to do the box. Volume is the same thing as length times width times height. Volume is length times width times height. It's telling you the height, h equals x plus 3. That's the height. So if you wanted to factor this, you take your negative 3 and divide into this.
It is now the end of first
For you
period.
Zoomers, I'll go ahead and finish this problem off.
Mister, how is attendance going to be due today? Because it wouldn't let me take the form.
Can you say that one more time a little louder?
How do we do the attendance? Because it wouldn't let me do the form.
I'll add it here in just a second.
Okay.
So find the expression representing the length and another expression representing the width. What that means we need to factor this. So factors of -28 that add up to 3 are going to be 7 minus 4. So we have x plus 7 and x minus 4. So one of these will be length, one of them will be width. We'll call this one length, and we'll call this one width. If the longest side is supposed to be 18, find the volume of the box. So the way you solve it, so yeah, is you set these up and say if the longest side is supposed to be 18, so it's either x minus 4 equals 18 or x plus 7 equals 18. You would see which one mathematically gives you a bigger value. You'll find out it's not this one because that gives you x of 11. Whereas if you had it this way and you solve this, you'd have x equals 22. So we're not going to use that one. We're going to say x equals 22. If that's the longest side, find the volume. You could, if you type this in the calculator, just put in 22 next. So x cubed plus 6x squared minus 19x minus 84. Looks like there's a cheat. It tells you the zeros right here. Remember, that's the zero, so you go as a factored form, and so that all of them will lie. So that's where that's the height, x plus 3. We'd also have x plus 7, x minus 4. Here those are. And if you want to know what happens if your x is 22, that would be your volume right there, 1350. $13,050 rather. And let's say inches, okay, inches cubed. And that would be your volume right there. Sorry I ran out of this problem, but just remind yourself as you work this, the key to do this is to do the, what's it called? Fundamental rule of division, where you switch your signs. So here, this would be, whoops, x cubed, and you distribute across. That's going to be the idea here. You need to switch your signs. Oops, that's supposed to be a 4, sorry.
Mister, and I'm guessing this was the chapter 2 review.
Yep, it's chapter 2 review attendance.
All right, thank you.
Gosh, trying to go fast, I'm just making mistakes. Here it is, x cubed minus x squared. So here, so I don't forget, it's switch the signs. That's the big key. When you do this, is to switch your signs, you get a remainder of -5. And so that's your
The time is 10:50. It's the beginning of second period
quotient.
and A lunch.
That's your remainder. All right, take care.
Mister, are you gonna put the attendance?
Yeah, I'll update it. So